Okay, so far in this chapter we've done the distance and the midpoint formulas in 9.1. We did the parabolas in section 9.2. We did the circles. These are all conic sections. Okay, now we're in section 9.4. We're going to go through the ellipses. Okay, definition-wise, an ellipse is a set of points in a plane such that, and for those of you that go on in math down the road, such that is going to be a backwards epsilon. Okay, mathematicians are lazy, we're not going to write everything. Such that for each, okay, and for each, for all, for every, for any is going to be an upside down A. Okay, for each point in the set, the sum of its distances to two fixed points called foci. I think if it's foci, I'm not sure, I think it's two I's, if it's plural, is a given constant. A given constant. So an ellipse is a set of points in a plane such that for each point in the set, the sum of its distances to two fixed points called foci is a given constant. Picture-wise, it's going to look like this. All we need is a sketch. They're going to be, and on this one, I'm going to put the center of the foci at the origin. So the center is going to be here. Okay, and let's go out. Let's go out 4 and -4 for the foci. And what you do is you basically create an ellipse. It's going to look something like this. It's going to look like an oval, but we call it an ellipse in math. Mine's a little off. But those two foci points, this was the foci is the ordered pair C0. This one is the ordered pair -C0. And the distance from this point to a point on the ellipse to the other foci, the distance is a constant. Like if that distance was, I'm just making up a number, if that distance was 10, then this distance would also be 10. Okay, if I said then this distance is also a constant 10. Okay, no matter where you draw that, okay, the distance is a constant between those two foci points. Okay, and examples, they used to have elliptical pool tables, and they would put one hole here, just one hole, okay, and then the people that knew their math would know that to get the ball in that hole, they had to put the ball over here at the other foci point. No matter where they hit it, it would always go in the other point, because it would go boom, boom, land in the hole. It would go boom, boom, land in the hole. No matter where they hit it, it would go in that hole, as long as they knew where the other foci. So they would mark that other foci point. Obviously, that's why they outlawed elliptical pool tables. They were against the law because they were cheating. Some of you, if you've gone to Washington D.C. and if you go to the whisper chambers in the Capitol building. In the whisper chambers, you can stand, somebody stand at the foci point and whisper, no matter, where they're, as long as they're at one of the foci, and you stand over here at the other foci and whisper, it will bounce off the walls and you'll be able to hear them. If you're whispering at one foci and you stand somewhere else, then you're not going to be able to hear them. Okay, so and they also use an example of this is they use ellipses in lithotripsy for medicine. When they do like a kidney stone and they want to shatter a kidney stone, they used to do it. They would put the patient in a tub of water. Okay, they would put the kidney stone that they want to shatter at one foci, put the machine at the other foci. It would ricochet off the elliptical tub that they were in, and then it would shatter that kidney stone inside their body. Now it's just in air, I think, but it's called lithotripsy. So there are uses for. It's not just we're studying it to be graphing it and that's it. No, there are uses for ellipses. Okay, the longer axis. Okay, in this case, this would be what they call the major axis. It's the longer one. In this case, the x-axis would be the major axis. This one, it's the shorter. In this case, the shorter one is the minor axis. They're actually major axis of symmetry. I'm not writing all that down. And the vertices are always on the major axis. So the vertices are on the major. The co-vertices, this would be a vertex. This would be a vertex. This would be a co-vertex. Okay, and so would this one. So the co-vertices are on the minor axis. Okay, and the foci are always on the major. I guess it's just one eye. The foci are always on the major axis. And you might say the major axis is the longer axis. It's always the longer one. The minor axis is the shorter one. Okay. Okay. Now there's we're going to go through first two main formulas where the center is 0, 0, and then we'll go off center. Okay. So the ellipse having, and that's like the one I just drew, having foci at -6, 0, -6, 0, and C0, or C, sorry, -C0 and C0, and the sum of the focal radii is equal to 2a, has the equation okay, and here's the main equation: x squared over a squared plus y squared over b squared equal to 1. This is the main equation if the center's at 0, 0, and the major axis is, and you can tell by looking at the first term, the major axis is the x-axis. Okay, and it's always on an ellipse. It's always the clue that it's going to graph an ellipse is it's an x squared and it's a y squared and it equals 1. Okay, and c squared equals a squared minus b squared. So the a squared on this one, and this is like the one that I've drawn up here. The major axis is the first axis. The a squared is underneath that, so you can sub that in. The b squared is underneath the y, so you can sub that in. You can solve for C, and then that gives you where the foci are. Okay? Yeah, negative C0 and C0 is your foci. Yep. Okay, and on this, the length of the major axis is equal to 2a, and the length of the minor axis is equal to 2b. So if you looked at your picture, the major axis on this picture is the x-axis, the center's at 0, 0. But that's telling you from here to here is what letter? A. So the major axis would be 2a, and the minor axis from here to here would be b and b. And then the foci would be at C. Okay? Okay, so put this in a box maybe to highlight. This is if the center's at 0, 0, and your major axis is your x-axis. Okay, the next part. This one is the center's at 0, 0, and the major axis is your y-axis. Okay? So on this one, the ellipse having foci at 0, negative C, and 0, C, and the sum of the focal radii is equal to 2a, has the equation okay, here's the main equation, y squared over a squared plus x squared over b squared is equal to 1. So if the y squared is your first term, then that's your major axis. Your major axis on an ellipse is that first term. It's written in that form. Okay? And still have c squared equals a squared minus b squared. Aren't those the same? The c squared formulas are the same. Yep. And on the length of the major axis is still 2a, and the length of the minor axis is 2b. This one, the major axis would be the y-axis like that. From here, oh sorry, should be 2b. Thanks. 2b. This should change that to a b. Yeah. So from here to here is your a. Okay, that's your a. So the length of that major axis would be 2a, and from here to here would be the b. Okay, to the co-vertices. And the foci on that would be somewhere on this major axis, and that would be from here to here would be your C. Okay? Okay. Okay, so they will give you some problems now. Say it asks you to write an equation for an ellipse. They're going to give you the graph. On the x, go out 3 to the right and 3 to the left. On the y, go up 5 and down 5. Okay, and then do a smooth curve. As best you can, a smooth curve. A little crooked. Okay. Okay, so our major axis is the longer axis is your major axis. So it's y squared over, and your a value is, yeah, the a value is 5. We went 5 up, 5 down, so this is 5 squared plus, it's always going to be a plus sign on an ellipse. And then the minor axis is x squared, and then 3 squared, and it's equal to 1. Now, you can write it like that, or sometimes the author will write it, and they go ahead and square them out. Okay, either, I don't care, either way. Okay, and the center's at 0, 0. Okay, let's try another one. That's it. Yeah, it's coming. Okay, on this one, still centered 0, 0. On the x, go out 4 and negative 4. Put your vertices. On the y, go up 2 and down 2 to put the co-vertices. Draw a smooth curve. Ellipse. Now what's the major axis? The x is the major axis, so it's x squared over 4 squared plus y squared over 2 squared equals 1. And you can write it like that, or you can write it x squared over 16 plus y squared over 4 equals 1. Either one of those will work. Okay? Okay, now, on both of those examples, we were at the center 0, 0. Okay, now we're going off center. Okay? There we go. Okay? Okay, so on this one, okay, on this one, go 2 to the right and go up 3. Put the center. We're going off center. Go 2 to the right and up 3. From that point, go to the right 4. Go to the left 4. From that point, go up 2 and down 2. Okay, and draw an ellipse. Okay. Okay, the main formula if you're going off center is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. 4. Okay. The center, instead of being 0, 0, the center is hk. My h was 2, so x minus 2 quantity squared. And you can tell the x, the one going horizontal, is longer. How far did I go? 4. So 4 squared plus y minus 3 quantity squared over 2 squared equals 1. And I could write the bottom as 16 and 4 if I wanted to. Okay, so it's not really that bad. Okay, now I do want to give you, because they're going to have you calculate some other things in this. If you're going horizontally for your major axis off center, okay, if they ask you for the foci, let's put all of this in a box. So if they do that, the foci in this, it's the ordered pair h plus or minus c and then a comma k. So it's your h value Okay, plus or minus the C value because you're going off center. Okay, the vertices, and the vertices are on the major axis, the longer one. The vertices H plus or minus A, and you can combine those, simplify them, comma K for the vertices. The co-vertices have the formula H, then K plus or minus B. And we already said our center is at HK. So basically you know the A, the B, the H, the K, so you can find any of those ordered pairs. Okay? So that's if you're off center and your major axis is horizontal. Okay? Everybody good with that? Okay, fourth example. Okay, on your graph, let's go one to the right, or no, excuse me, one to the left. One to the left and up 2. There's your center. Okay, from that center point, go down 3 and up 3. So go down 3 and up 3. From that center point, go to the right 1, go to the left 1. That should come through right there. Okay. Okay, so now this one, your major axis is vertical, so that means it's going to be a Y. It's off center, and this time it's Y minus K quantity squared. And remember, on an ellipse, the number underneath the first set of is an A. It's always A squared. If you look back at your notes, it's A squared underneath the first one. Plus, this one's going to go X minus H quantity squared over B squared, and it equals 1. The center on this is still HK, but you got to look at the order. Look at the difference between that one and the one we just did up above. So in this one, it's Y minus HK. The K is 2. The A, the major axis, 3 squared. X minus, or no, in this case it's plus, minus a negative 1, plus 1, X plus 1, quantity squared, right? Okay, and then 1 squared, sorry. 1 squared, because we went to the right 1, left 1, equal to 1. Okay, so the center, what was the center of the HK? Negative 1, 2. Okay, negative 1 to the left and up 2 was our center. Okay. Okay, and on this one, if your major axis is vertical, the foci H and K plus or minus C. And I don't expect you to memorize this part, no. The vertices, you just have to be able to use them. The vertices H and K plus or minus A. The co-vertices H plus or minus B, comma, K. Okay, now I want to go through an example. Last example. You might want to separate that. That's into this. Okay, find the coordinates of the center and foci. Find the coordinates of the center and foci and the length of the major and minor axis. If it's plural, it's AXES of the ellipse. With the given equation. And then graph it. And you may want to graph it first. Okay, they give you the equation. X squared over 36 plus y squared over 9 equals 1. So this one's, they're being nice. It's already at the origin. Yep. So we already know the center. The HK is 0, 0. Okay, to do the foci, you got to find the C. What's the A squared? But the A squared is 36, right? The B squared is 9. And you know the formula is C squared equals A squared minus B squared. So C squared equals 36 minus 9. So C squared equals 27. Take the square root of both sides. So C equals, I can split that up into 9 and 3, and what can I take out? So 3 radical 3. Okay, so we're actually on the, and if we could actually go ahead and graph this. We're on, this tells you the axis is, the major axis is the X, and we're on the origin, 0, 0. This tells you go out 6. This tells you go out 6 and negative 6. 1, 2, 3, 4, 5, 6. On the Y, you go up 3, down 3. Okay, so we should have a graph. Whoops, didn't quite hit it. Okay, we know the center. The foci are on the major axis, so there has to 3 radical 3. What's that in decimal form? Somebody got a calculator? Take 3 times radical 3. Give me a decimal. Five point 2, so a little bit bigger than 5. So go out 5. 1, 2, 3, 4, 5. There would be a foci point here, and a foci point over here. So our foci would be 3 radical 3, 0, and negative 3 radical 3, 0. So they wanted the center, they wanted the foci, they want the length of the major axis. How far do we go out on the X? 6. So the length of the major axis, 2 times 6. Yeah, 2 times 6 would be 12. And the length of the minor axis, this would be the major. And the minor axis, yeah, it would be 6. And we've got the lengths, and we've graphed it. Okay, so they asked for the center. Help your grader out. They asked for the center. They asked for the 2 foci. They asked for the length of the major and the minor, and they asked you to graph it. Okay? Okay? Any questions on that now?